What is the value of, wait, what is the value of the test statistic? Isn't that just a formula?
Is that the T? Is that T or no?
Uh-oh. No.
It might just be
Yeah,
crazy.
T equals parentheses D minus 0 over, what did it say?
Oh, this is
Sorry, you're gonna have to listen to this for a second.
That's fine.
I just
scale
realized I was hecka close
that
to the
have is
computer.
our son's taller than dad's.
Okay.
So, for instance, if we
Where'd it go? I just had it.
then I'll follow it up with
Oh,
comment,
yeah.
and I'll wrap it up.
It's that formula.
For one sample C, which was from the last test, we take our
Okay, yeah. S over the square root of n.
Oh, and it's D minus 0 for the difference one.
Sorry, what?
It's, or wait. Yeah, it's the D minus 0, right?
Yes.
Okay.
That's a paired sample, and then the one sample T is x minus mean over S divided by the square root of n.
Okay, yeah.
So which one would we use? Which one?
So,
Isn't it a paired?
oh, I guess it would be 0 anyways because the
Oh, because the mean is 0.
UD is 0.
So you'd use the D minus 0 one?
Yeah.
Okay, so D. It's 2.2 over, is that S over square root of n?
Yeah.
Okay. So 3.3 divided by the square root of 9. Okay. Sorry, I'm like talking out loud. I was like,
That's fine.
I'm so out of it. Ugh, okay. 3.3 square root of 9 is 3. So it's, okay. I'm ready when you are.
Okay, I got 2.
Me too. 2 even. Sweet. We're so good at this.
Hopefully.
Hopefully, because I need to do well in this.
Yeah.
Okay.
Okay.
The probability of being greater than 2 is 0.0403. Use H to determine the p-value for this test. What formula would we use for that?
Um,
For p-value? Isn't that just... Shoot, I don't remember how to find the p-value.
no.
Isn't that from like 2 lessons ago?
I think so. It was either,
Yeah, I don't remember here.
I'll look in lesson 10.
Okay.
Maybe.
Uh,
Okay, so it's, oh wait, maybe that's not it.
I'm not finding it either.
I think it might be in this section.
In this section we're now?
Or in lesson 10, sorry.
Okay. Oh no, you're fine. I was like, wait, how am I not seeing it?
Yeah.
Oh. Shocked me.
Maybe. It might be in lesson 11.
Yeah. Where in the world is it?
Okay, the p-value equals... Oh, never mind. That's not it.
Everything I'm finding just says p-value equals, and it's like the
Yeah. Same here. Yeah, I can't seem to find it.
yeah. You're looking at 11, right?
Well, now I'm looking online.
Okay. I'm looking through her stuff,
Okay.
trying to find the. Because we've been doing p-value for a while, huh?
Yeah, I think so.
I don't think it was. The p-value is the applet.
Oh, is it?
Yeah.
I guess that would make sense because it would be the ends, huh?
Yeah.
Okay.
It's not giving me. I'm in lesson 9.
Okay.
There's no like formula, you know what I mean?
Yeah.
So how do we do that?
So I think we probably have to find the z-score and plug that into the
Applet.
applet.
Ugh, gross. Z-score. Now I have to remember that formula.
So the z-score. Oh, so the z-score is the same thing as our or our test statistic.
Okay, yeah. So that's 2. So we just have to put 2 into the applet?
Yeah, I think so.
How does the 0.0403 come into play then? In number 4, it says the probability of being greater than 2.
So we'll put in 2. I think, well, Hold on, let me pull up the applet and then.
Yeah. Let me see if I can find it. Where are you, applet? I was looking way back.
Yeah.
Or actually, it'd be easier to do it this way. There it is. Okay, so you're putting in 2,
Yeah.
and then are you gonna what areas are you highlighting? Just ends, right?
I don't know yet. Wait. So.
I don't know where that 0.33 thing comes in.
That's what I'm trying to figure out. Because if you look at the area on it, it's 0.0455.
Yeah, that's what I got.
So maybe just plug in the 0.04303. Sorry.
0.0403. Oh, well that
Because I mean, I guess maybe
that jumped it, yeah.
yeah. Wait, of it being greater than 2. So maybe wait. I don't know for sure. Since the probability of it being greater than 2.0 is that, would you only highlight above 2 and put in the 0.0403?
Wait, so what are you putting as the z-score? 2?
I thought maybe so, but I don't know whether or not we need.
I can go through the reading again. I swear I.
Okay, so in the reading, it has a little graph like the applet would, and it says the test statistic, or T, is labeled on the horizontal axis, and then the
Yes.
p-value is the area to the
The
left
left.
of the T. But I still don't know where that one.
This area is so small it is not illustrated on this plot. Please note that this image was taken from a normal probability applet. The test statistic of the 2 means.
Yeah, I guess I still don't know where that 0 point. And I don't know.
Should we just not worry about it? I feel weird. Because the T is our z-score.
Yeah.
And then to compute the probability.
Because if we weren't supposed to use the
Is
above
that not,
information on it, maybe.
well, yeah, maybe we weren't supposed to, because it says like this is only for illustrative use. Maybe the 0.0403 is like our significance level.
Yeah, like maybe.
But wouldn't they just say A equals? And then it says use A.
Because like the probability, isn't that like the area on the applet?
Yeah.
That's what I thought. So maybe just highlight above 2.
Okay.
No,
Well, if you highlight just above 2, you get.
Then that would be, the p-score would be the same as the 0.4.
I got 0.0228.
Oh, yeah. Yeah, if we just go with 2.
But I don't know if that's right. Should we just do that?
Yeah,
We'll probably get it wrong, but
I don't know how to do it, though,
I don't know
so.
how to do it either, yeah. So I put in 0.023.
Oh, yeah, because 2 is a third.
Okay. And then what is D? So that's using the software, right?
Yeah.
Okay. Mm,
So for this, what do we... Okay, so I understand you, like, find how to find the difference. Have you done it yet, or no?
yes, I did the difference already, yeah.
Okay, so I got that. Then what are we supposed to choose when we compare the means?
Okay, I'll start over so you analyze, descriptive statistics, explore, and then you put the difference in the dependent list.
Oh, okay.
So you bring that over. So click on the difference and then press the arrow.
Mm-hmm.
And then you press plots over on the right.
Okay.
And then click histogram. So like make sure that's checked.
Mm-hmm.
And then click the normally plots with tests.
Okay.
And then make sure factor levels together.
Okay. And then
I
just
think
continue.
that's it. And then continue and then okay. And then make sure it's displaying both. And that should bring it up. At least it worked for me. I don't know.
Yeah. We'll be able to tell when.
Yeah. So the D is which box? Let me see.
So wouldn't it be the mean?
Yeah. So the mean is negative 31.0250. Is that what you have?
Yeah.
Okay, negative 31. Do you want to write it down and then you can tell it back to me?
Yeah, I can do that.
Okay. So it's negative 31.0250.
All right.
Okay, and then we flip it over. It's kind of hard going back and forth. Okay, so
I
it's
know.
negative 31.
1.0250.
Okay, do we have to round? Oh, 3 decimal places, so
Oh.
just 0. So the SD, that is, isn't that the? Sorry, go ahead.
Is it the standard deviation of it?
Yeah. So it's okay, 341.15713. So 341. No, you're fine. 0.15713.
All right.
Okay. So sorry, what was it?
341.157.
157. Okay. The test statistic, and that's just the z-score, basically, right?
Yeah. Do we have to figure it out? I think so.
It's not just there. For some reason, I felt like it was. It's not the degrees of freedom, right?
I don't know.
Maybe just compute it.
Yeah.
Okay, so to compute it, we need to do. Oh crap! No, I don't remember the formula.
It's the
minus 0 divided by standard deviation over n, right?
Yeah.
But we don't have an n.
So n was 20.
Where did you get that from?
Because that's how many samples there were.
Oh, duh.
It's okay.
Sorry. So you're going to do negative 31.025 over 341.157 over the square root of 20.
Yeah.
Okay. Okay. I got negative. Are you ready? Sorry.
Yeah.
I got negative 0.4068.
Yeah, that's what I got too.
And that's rounded right. So 0. Oh wait. Oops. 40. So you can do 407.
Yeah.
Okay. What is the correct decision based on the evidence? Rejects the null
What is the p-value is first.
Oh, I was accidentally put that in as the p-value. Sorry.
Oh, no, you're fine. I just didn't want you to.
Yeah, no. I would have been super confused. Okay, so the p-value, that's one we. Oh, isn't that on the stuff though?
Well, so this one, I like watched the videos,
Me too. Yeah.
and since this one is the, I guess like the whatever of difference,
Yeah.
could we just use that the
0.053?
I don't know.
Isn't it the sig test?
Yeah.
So, but it doesn't look like it's two-tailed. Like, does yours only show one? That makes sense?
I don't know. The histogram?
Well, it says test of normality, right? Like that little box. And then it says statistic, DF, and then sig.
I don't
Isn't
see
it?
that box.
You don't see that? It's under.
Oh, okay, yeah. Yeah, I do see it now.
So it says sig 0.053. Isn't that it?
Yeah.
Okay.
I think so.
That's what I think. But
Yeah.
I'm not really good at this, so.
I know. Yeah.
So we would fail to reject, right?
Let's see. So the alpha is 0.1.
Yeah, and this
So
is.
it's less than. So yeah, I think we failed to reject.
Yeah, because it's greater than. Actually, no, it's not. Wouldn't we reject it?
Yeah, I was gonna say I think.
I had it flipped. I was thinking it was going to be 0.5. I just assumed it was going to be 0.5. So.
Oh yeah.
Yes, we reject the null hypothesis.
Yeah.
So select your alternative hypothesis. Suppose your internal hypothesis is that. What is the correct decision based on this evidence? Wouldn't we still reject it?
I think so. I mean, if we rejected it before.
Because I don't think it really matters what the alternative is, as long as it's.
But if greater than 0 makes a difference.
Yeah. What was the original?
Wait, if it was greater than 0, it would only be one-tailed, right?
Yes.
So we would divide it by 2, but it would still be smaller.
So we'd still fail to reject.
So
or reject
we
it.
would reject. Yeah.
Sorry, that's what I meant.
Mm-hmm.
Alrighty then. Okay, so it's a new.
Oh, there's another. I didn't see this one last.
Cool. I'm gonna have to exit out of all this and do it.
Over here. On the counter up there. On the counter, it doesn't look like I scratched one, but it is.
Mine isn't working. Is yours? Mine's saying variable name contains an illegal first character.
Oh, did you start it with a number?
My target variable?
Yeah.
No, I said difference.
Oh. Does it have a space maybe?
No. Oh, it went. That was weird.
That's okay.
Okay. Okay, there it went. Okay, so analyze, descriptive statistics, explore, plots, Instagram. All right. It's probably gonna ask for the same things.
Yeah.
Which is greater, N or DF? Oh, the DF
Is N minus 1.
Yeah, and then the N is just how many, right?
Yeah.
Okay, so then is 22, right? Yeah, 22. And then the DF is what did you say it was?
The DF would be N minus 1.
So wouldn't the N be greater?
Yeah.
Sorry, that took me a long time. So your alternative hypothesis, and you use a level significance of 0.01, what is the p-value?
So this one we would just use the sig, right?
That's what I think.
Okay.
It'd be 0.200. So basically 0.2. Right?
Okay. Yeah.
And then we would fail to reject, right? Or no, we would reject it. Right?
We would fail to reject because it's greater than 0.01.
Yeah. Sorry.
That's fine.
I'm like going crazy. Okay. So you decide to try another alternative hypothesis. This time you use that, and you keep the same level of significance. Did the p-value increase or decrease?
So the p-value is going to decrease, right?
Because it's greater than, yeah.
Yeah.
But then wouldn't we still fail to reject?
Yeah, because it would still be greater.
As we've seen, the p-value depends on the alternative hypothesis. Setting aside the data in this problem, do you think a general rule can be made? Which alternative hypothesis will make the smallest p-value? Isn't it greater than?
Wait, the smallest p-value. Well, wouldn't the smallest p-value be greater or less than?
Well, because for number 14, it was equal to, and when we made it greater than, the number decreased.
Yeah, but wouldn't it also do that if it
was greater or equal to?
Yeah, well, greater than or less than.
Yeah. Or yeah, sorry, that's what I meant. Not equal to. That's what I should say.
Yeah.
Yeah, that makes sense.
So I don't know. I guess maybe not enough information.
Well, maybe are we doing the wrong thing with the p-value? Because maybe we're not. Maybe it isn't the same, and we're like.
That's what I was just thinking.
Maybe that was too simple. Like, how do we know it decreases? I feel like we have to do something. The formula.
Well, I think in lesson 11 it tells us how to find the p-value. Like if you're given it from SPSS.
Yeah.
So, but I thought it said divide by 2 if you have a one-tailed.
Yeah, that's all it said. But I think I can't tell. But here's my concern. In the test of normality where we got the sig value, it doesn't say it's two-tailed. In the before, it did.
Did it?
I feel like it did.
When it said the one sample test?
Yeah, so maybe this one's already one sample because it's one column of information, you know?
Mm,
It's not a 2 sig test. So we wouldn't divide it by 2 because it's already divided. Does that make sense?
maybe.
I don't know.
Um,
I'm fine with just submitting it, but if you want to,
let me say, I might look
you might what?
into it and try to figure it out.
Okay.
But I just want to see something real quick.
No, you're fine. I'm messing with it too. I'm going through the reading.
Yeah. So I did the one sample test because I didn't know whether or not we'd do that on the SPSS.
Yeah.
And what did we get for our, wait, no. Then for our SIG two-tailed, I got 0.001.
Wait. How did you get that?
I just did the, went to analyze and did compare means. I did
Okay.
one sample t-test.
And you
And
got
I don't
what?
know if we're supposed to do that for this.
I don't think we're supposed to do that. It didn't give us, like, it never told us to do that.
That's true.
Just maybe. DF is the degrees of freedom, not
Yeah.
the.
Isn't it the same thing? Or no?
I don't think it is. Where did we find the DF? Where did we do that? I'm trying to find the problem it was. N is 22, and the DF is oh. It should just be right there. It should say T and then DF. So our DF is 22 as well, so they're the same thing. That's what the chart says, at least.
See, yeah. Which confused me, because I thought that DF was n-1.
Maybe it just doesn't do that. Maybe it just doesn't compute it. I'm not sure. I'm just like down. I'm going back on everything, you know, and I'm like looking.
Yeah. Let's see. Yeah, so for, I don't know, I don't know, in chapter 12, I just searched for DF and it was the n-1. So.
Yeah. No, I'm fine with that.
Yeah. I don't know, I guess we could just submit it and hopefully, I don't know.
So, found something. No, that's already what we know. Oh well, yeah, I'll just submit it. I'll just